All right, so we're going to be moving now finally into Unit 3, and you can see up on the screen here, I still have my Apple Pie app in the background running, so I should probably kill that, or stop it, I should say. I don't want to kill it, I want to just stop it. But when we get to Unit 3 here, we're going to learn a bunch of new high-level features of the Swift language. Some of this stuff does have, I'll say comparables to other languages. Like, for example, enumerations is something that we do see in other programming languages. Scope is something that's pertinent to other languages. But then we see this thing called optionals, right? This is kind of, I'm not going to say it's uniquely Swift, but it's very Swifty the way that it works here. We also have typecasting, which is a feature of other languages as well, but we'll learn how Swift does it because it's a little different than most languages. And then we'll learn how to do guard statements, which we'll often do like guard let. And that one, I'll tell you what, when I did the certification exam on that, I think that was probably the hardest thing for me to wrap my head around because it was a really kind of a completely new concept. We've already done if lets, right? So like if something is true, we then populate a constant. And guard is sort of like that. And you'll see when we get there. So what I'm going to do here is I am going to move into the first one here. We're going to open the optionals playground. I'm going to go ahead and trust and open. I should probably come back here to Xcode and go ahead and maybe just close this project at the very least to free up some RAM. And we're just going to do like we've normally done with all of our playgrounds is we're going to read through the material. We're going to try to execute the code and complete the tasks. I may at times refer to the teacher manual to help guide us. And let's see how much of this we can do without a wire. But I'm a teacher, so I'm going to use my cheat sheets anyhow. By the way, right? I always like to make sure that I'm staying on track. So I'm opening the teacher version. It's going on the other screen, and I'm hiding it from at least from YouTube people. Right. So let's read this, and you'll apologize if I read verbatim. I think in some cases it's appropriate. So it says, throughout the exercises in this playground, you'll be printing optional values. The Swift compiler will display a warning. Expression implicitly coerced from int ? To any. So for the purposes of these exercises, you can ignore this warning. So basically, don't freak out is what that's telling you, right? It's expected. I'm also keeping in mind, I'm on Xcode 14 as I run this. My students are on Xcode 15. I should probably take it upon myself to upgrade, but I will eventually do that. So I'm just saying that in terms of reference for anybody that might be watching the video in the aftermath. All right, so let's read the scenario here. Imagine you have an app that asks the user to enter his or her age using the keyboard. When your app allows the user to input text, what is captured for you is given as a string. And this is true for all computer interfaces, right? So like, whether you're coding for the web or you're coding for an app or console or GUI, all the interchanges to the screen, whether you're sending to the screen or receiving from the screen, is always, the text is always a string, even if you type in a number. And it says here, however, you want to store the information as an int. Is it possible for the user to make a mistake and for the input not to match the type you want to store? That's a good question. So it says declare a constant, and they give us a name here. So let's go ahead and just start building this. I'm going to say let, and what do they want us to call it? User input age equal, and the person wants to type 34, but they want us to mistype and say E, right? Now, we know either way, this is text, right? Why do we know that? Because it's inside double quotes. And you can confirm that, of course, by just hovering and do the option click thing, right? It'll tell you, look, it's a string, right? Just to confirm. Okay, so then it says declare constant user age of type int. So we'll say user age, a colon, we'll declare it as an int, and set its value using the int initializer that takes an instance of string as an input and pass in user input age as the argument for an initializer. So what error do you get? And so I'm not putting the question mark in. And I think some of us have already figured out, and you notice it's already thrown the error, right? But we would take the previous thing that we created and feed it in. And notice it does throw the error. And notice the error, right? So we encountered this building the Apple Pie app. It says value of optional type int question mark must be unwrapped to a value of an int. So in order to make that happen, we put the question mark here that should make the error go away. And now notice in the sidebar, what is the output? It says nil, right? Because what we're feeding in above 34E cannot be converted to a number. If I remove the E, right, and that's what they're going to ask us to do here, notice how now it can correctly convert it. Now, the whole point of, putting in the question mark there, so I'll just type in the letter again, is right now we don't have a value, but we're relying on something else to give us a value. And we call that an optional. This is something you do see in other languages. So other languages that use this sort of terminology, not the exact same syntax. I recently taught a C# class, and in C# they have this mechanism as well. So you often, especially with strings where you're expecting input from the user and the user hasn't typed it in yet, but you've already declared the variable, it makes sense to set it as an optional, because what if they don't type anything in, they just press enter, right? It's blank. It just allows the program to not crash. So you can go ahead and adjust that if you wish, right? So it tells us basically, what we're doing there. All right. So we did that action. Right. If you want, you can type in the answer here. And this is what the author has in there. So I'm just going to copy paste this from the author's solution. So if we print the user age, I do want you to notice here in the sidebar, right? And it labels it as an optional. I think this is really kind of neat that it does that. And it says also as a warning, not an error, that expression implicitly coerced from int to any. That's the thing that they were telling us about before, right? Yellow things like this don't stop your program from running, right? They're just saying, hey, this is not a good idea, right? So if we're going to print that, it would work, but it is an optional. And the reason that they have declared user age is nil because 34E cannot be properly converted into an integer because of the character E. Okay, we figured all that out. Now it says go back and fix the typo. We've already done that too. Is there anything about the value printed that seems off, right? Print user age again, but this time unwrap the user age. So this is where we learn what the exclamation point actually means. I think when we were doing the Apple Pie app, it wouldn't have been nice to have this information before, right?
Yeah, right.
We would have totally understood what we were doing. But you know what? I'll tell you what. But there's kind of a flip to that too. The flip is sometimes you do stuff, you struggle with it, and you figure out why it's not working. And then you go, oh, then you read up on it and you go, oh, that's now and it actually makes more sense when you're presented with the information. Whereas if you're presented with it now, you're like, I don't get it. What's the point of this? Right? But we saw a real life example of why that's important. Now notice by just putting the exclamation there, that's the only difference between this statement and that. We get rid of the warning and it unwraps it and takes the optional into consideration. So it keeps us from getting those warnings basically. All right. Now it says, use the optional binding to unwrap user age. And if user age has a value, print it to the console. So the way that we do that, we're going to do that in the form of an if-let statement. So we're going to say if let age equal user age. And then we're going to print and we'll see that it works, right? So in other words, this terminology, and right, once again, this is a little bit deeper of a topic, conceptually than any of the stuff from like, the first course that we did. So what the reason that we have this set up like this, so I just want to kind of backtrack here. If I go back here and throw an E in here now, watch what happens. The unwrap, not only do we have a warning, but the unwrap doesn't work, right? It never even reaches this point, right? And so does that really, I'm going to say fix the problem? Not necessarily, but the point is, if it does work, that we can assign or we can do stuff programmatically, but the let doesn't get set unless it's true that we can set it. That's really the point, right? All right. Let's move on to the next page. All right, so on the next page here, we're going to work on this heart rate thing. It sounds like we're back to our fitness tracking app again. And it says, all right, so there's a lot of APIs that you'll end up using that give you information gathered by the hardware return optionals. For example, an API for working with a heart rate monitor may give you nil if the heart rate monitor is adjusted poorly and can't properly read the heart rate of the user, right? So here they're asking us to declare a variable heart rate of type int question mark, set it to nil and print the value. All right, so let's try that. Here's, and they do want this to be a var, and we're going to say heart rate. It's going to be of type int and optional, and we're going to set that to nil. All right. Then they want us to print the value, so we're just going to print heart rate, and then you'll see hopefully nil in the margins. Right. Notice the warning popping back up. Right. So it says in this example, the user fixes the positioning of the heart rate monitor. The app may get a proper heart reading. So they just adjust the things a little bit, or the wire was unplugged or whatever, make sure it's plugged in, and so what they want us to do is they want us to update the heart rate. So they want us to say heart rate equals 74 and then print the value. Ideally, once again, it shows as an optional. And yes, the error message is expressed. Don't freak out to that. I think we've already said that. All right. So it says here, as you've done in other app exercises, create a variable heart rate average of type int. Use the value stored below in the value of heart rate to calculate the average heart rate. So we have some given. So these are already created, so we don't have to create those. But we're going to use the if let statement now to pull that all together and hopefully do an average. So let's type that in. So we'll say if let HR for heart rate. If that equals heart rate, then let the heart rate average, spell it correctly, will equal, we set a parentheses here, right? Because when you do averages, you always have to remember that. So we're going to take each one of these heart rates and add them together. We'll add each one in. And then we'll divide by the total number of them. How many are there? Oh, we also need to add the current heart rate. I apologize. So HR. And then divide by 5. And then we will print Notice, you know, so far it works just fine. But what happens, and just keep reading here, and I'm going to scroll. If you didn't unwrap the value of heart rate, you probably noticed that you cannot perform mathematical operations on a heart optional value. You first need to unwrap it. So where does the unwrap happen?
I want it to be on line 14.
On my line number 22.
Oh, yeah.
Yeah. So
No.
so this is the spot where it's unwrapping, and that's how it's reading this. So this doesn't get set unless this statement is even possible. So if heart rate did not have a value, right, this would not get set, and then this would not work, right? So what we're looking, I mean, you have to remember we're doing an if statement, so this has to ring true. The ability to set this has to ring true for the if to be true, right? Right. So if I, for example, get rid of that, now watch what happens. Nothing is set. So that process of setting it here, because it's an optional, right? The program doesn't crash, but it's an optional with the value in, then the if let can work because we are unwrapping heart rate in order to have it here because that's an optional. That's kind of the point. Now there's an else we're going to add here. So we're going to test this, of course, by removing the value. We can omit the new heart rate, right? And just do the math with the old heart rate. So you could copy basically what I'm saying is these two lines and just tweak them rather than retype them, right? And we will remove plus HR at the end. And we'll change the 5 to a 4, right? And then come up here and comment this out like so. And notice the difference. So this is not being unwrapped because there's no value. So heart rate is nil. So we'll just use the old heart rates to do it, right? So it's not finding this to be able to create that constant. So it's just going with the other option. All right, hopefully that makes sense. And, turning that variable on and off is really kind of the, I guess, the magic sauce there. All right, moving on to the next one, folks. Right here it says if an app asks for a user's age, it may be because the app requires a user to be over a certain age to use some of the services it provides. It says write a function called check age that takes one parameter of type string. The function should try to convert this parameter into an int value and then check if the user is over 18 years old. If they're old enough, print welcome. Otherwise, print sorry or whatever. And then if the string parameter cannot be converted to an int value, print something went wrong. So we have a few different scenarios there. Can you please re-enter? Call the function and pass the user input age below as a single parameter, then call the function and pass in a string that can be converted to an integer. So we're going to try each of those things, but we need to build the function first. All right. So here comes the function definition. Right. So we're going to say func check age. And then we need to set this up here. So we're going to name it. It's going to be of type string. And then the return value will be an integer with an optional at the end. Why? Because what if they mistype it? What if it can't be converted? That's the point, right? Now we're going to do an if let here. So we're going to say if let age equals function converting age. So we're going to age should be inside those params. Sorry about that. So if that can work, then we'll proceed with the following task. We'll say, then again, now we're going to check to see if they're over 18. So we're going to say if age is greater than or equal to 18, curlies, we're told to print welcome. Else, we're given the text here, so we can just copy it. You don't want kids using the app, they might actually get fit or something. Forbid. And then when that's complete, in the true part of the if lot, then we will return the age, right? Because we were able to convert it, right? And then whether they're of age or not, we can proceed. Now we'll add an else to this. Why? To handle the situation where it cannot be converted, right? Whether or not they're of age or not. Once again, we'll have a print here, double quotes, and the message is provided above. So we can just copy it from here so we don't have to type it. Okay. The other thing is we are expected to return something, right? So we still have to have a return statement. And because we have nothing to return, we're going to return nil, and thus the optional here, right, with the question mark. That's why we do that. Because if it returns nil, and this is expecting an int, well, then we're going to get an error message. It should see the error message, right? So sometimes it helps to trigger the error message to understand that it is an error if we omit it. All right, so now we have to do a little bit of work here. We got to run this a couple of times. So the first thing that we're going to do is we're going to, and they tell us here, right? Call the function and pass in user input age below as a single parameter, then call the function and pass in a string that can be converted to an integer. So let's try this approach first. So say check age. What are we going to send in there? We're going to send in user input age. Notice already the response to this. See that, right? Sorry, something went wrong, yada, yada, yada. And it's returning nil, so it's this part that's catching right now. They're also asking us to print this, so I'm going to do a print command. And we're going to call check age. And then here, we're going to throw in 17, because that can be converted, right? And I am getting an error message here, different than the one I'm seeing in the book. So are you guys getting the same error? I'm curious.
I'm catching up to you.
Okay. I'll
Same.
let this sit here for a second while you guys get a chance to type it in. Of course, our huge YouTube audience has the option to pause. We're in a live classroom setting here, so.
Okay, I got it. Mine's different. Mine just says expression explicitly concern course from int question mark to any.
So you're getting this error, Jomar?
Yes.
Okay. All right. So they are giving us a bunch of messages here, and now it says go back, update your function to return the age as an integer. Will your function always return a value? Right. And so I guess I built it with the return already there, and the answer to that, of course, is no. Now, if I remove the optional once again, does it take care of the error? Okay. right? So Jomar, if you're getting that error, but now they're saying nil is incompatible with the return type of int, right? So now that throws a different error, right? So I can't return nil because that's not allowable here. But you know what? You could probably, if you wanted, you could hard code a value, something like this, and that would kind of fix it. Right? But now watch my logic here. I'm going to flip this. I'm going to flip this, and then I'm going to change the E to a 34. And now watch the difference. Everything is okay. Right? Well, almost. Right. As the yellow warning pops up. But this can be worked with, right? This wouldn't crash your program. So I will be kind of on occasion flipping that back and forth to just kind of make that point. Now it says go back and update to return the age as an integer. I think we already did that. Where your function return a value, make sure you return type accurately reflects this. Call the function and print the return value. So let's do another example of this. I'm going to copy and paste in this code. So we're just basically checking it again. I think we've already proved the point here. But this is what's in the teacher manual. So I'm just kind of putting it on the screen. Somebody took the trouble to type it. So, right. And notice, this one, of course, grabs the value that's set up here. This one is us, forcing a value in as a string, allowing it to convert, and then hopefully getting a value from it. The grand point is, if this can't convert it, all of this is off the table. Then you better be prepared to handle this. Right. So that's, I think, the grand takeaway here. Now, there's more. So let's move on down here. It says, imagine you're creating an app for making purchases, right? Write a function that will take in the name of an item for purchase as a string and will return the cost of the item as an optional double, right? And so now what you're seeing here, you guys remember what this structure is called? And I forget. So once again, I was in Python mode all morning.
Is it a key value?
Yeah, it's a key value pair.
That's it, key value pair.
Right. And in most languages, historically, they call it an associative array. In Python, they call it a dictionary. And I forget what they call it. I forget what they call it in Swift, but you know what? That's why we have this option click thing, because it'll tell us basically, it's basically an array. It's a key value pair. And I don't know that, gosh, I don't know if they tell us any more about like what they formally call that structure. So I think it, okay, well, it's
called a dictionary.
Yeah, right there. So it is a dictionary here in Swift, just as it is in Python, right? Thank goodness, some syntaxes. But the point of dictionaries is that instead of ordering the contents, it's like an array, but you're not ordering the contents with an index value. You're ordering it with the thing on the left is the key. That's the lookup thing. And then the value that we're actually storing here is, in this case, a double. There's no rule as to what has to be the key or what has to be the value. It could be an int, it could be a string, it could be a float in any of those positions. It's just a matter of how you choose to operate. In this case, we're listing products. So having the key be chips and the value be $2.99, which is the price, that works, right? We have prices, then we also have stock levels. So we have the stock level for chips is 4, donuts 0, of course, and juice is 12, etc. All right, now we want to write the function. In the body of the function, check to see if the item is in stock by accessing it in the dictionary stock. If it is, return the price of an item by accessing it in the other dictionary called prices. And if it's out of stock, return nil. Call the function and pass in the string that exists in the dictionaries below and print the return value. All right, that's a mouthful. All right, so let's start writing the func. I am also keeping an eye on the clock here. I think we're doing pretty good on time so far. So we're going to call this price, put in our parens, and I'm going to go, oops, I'm going to go back in, sorry, and fill that in. Totally hit the wrong key here on my screen, so I apologize. All right, so we're gonna name it item internally, and then we're gonna declare it as type string. The function will return double because it's gonna return the price. And only if we find that it's in stock, right? Because if it's not in stock, what's the point? Okay, so we'll make it an optional. Here comes the curlies. Now we're gonna go back to an if let again. So if let item stock, and that equals the stock item. So we're looking at the second dictionary right now. And what are we looking up? Whatever the item is, and that's going to be a string. So in other words, if I look up chips or donuts or apple or banana, right? So we'll create that only if the item is. So if the item stock is greater than 0, so we have some basically, then we're going to turn from the other dictionary the prices of, or the price really of that item. Right. That's if it's in stock. If it's not, let's put in an else. We're going to return nil. And I don't know why it ended up like that. I guess I wasn't watching as I was typing, but let's get the curly brackets in the right spot. Then we're going to do an else for the outer if. So after this, actually right here, we're going to add an else. And then if the item is not in the list, so like there's chips, donuts, juice, apple, banana, and broccoli, and I typed in cauliflower, you know, it's not even on the list, then also we will return no. Thing to remember is, you know, the if let, what it really kind of brings to the table is that, right? If we create this, if it's possible to, right? And in this case, we're looking it up based on the item that we'll be sending in. And so we don't get code that fails, basically. Yeah. All right. Now we need to test it. So we're just going to go right to print statements. I'm going to paste both of these in. These comes from the author's examples. I just want to save a little bit of time in typing. Of course, you guys have to do the character building and typing it in. But we're calling the price function. We're sending in an item, right? Which is expecting a string. So we're sending in donuts, we're sending in juice, right? You'll notice on the left there, donuts has a stock level of 0. So the output in the margin is nil, right? Juice does have stock. So it's bringing back the optional value of $3.99. Okay. Want to take it one step further, you could grab another one of these, you know, and I think this is probably helpful. Like, what if you put in a product that we don't have, like pizza? What happens then? Okay, well, it's still nil. That was the point. So I think that it's helpful to actually have that third example in there, because that hits the else down here. Now, of course, you could expand the dictionaries, add more stuff to them, and that's okay. You guys doing all right here?
Yeah.
Yep.
Pause for a second.
I think I am good.
I'm good.
Okay, ready to move on?
Yeah.
Okay. Let's move on to the next page then. You will notice we're importing foundation up here at the top. All right, so back to the fitness tracking app. Suppose you want your fitness tracking app to give users the ability to log food. And once it's logged, they should be able to go back and see what they had at a specific meal. Write a function, takes a string parameter where you pass in either breakfast, lunch, or dinner, and then it should return the meal object associated with that meal, or nil if they haven't entered that meal yet. All right, and it says no, the meal object and a dictionary meals representing the meal log have been created for you below. Call the function one, or I think they meant to say once or twice, but they say one or twice. I'm just breaking up the typo. And print the return value. All right, so let's take a look here. We have the struct, right? So we have the meal is a food, which will be a string, an array of strings. And then calories for the meal. Down here we see this meals structure. And notice what, this is a string, right, of meal objects. So in other words, this is a dictionary where we're storing key value pairs, and then inside each one of these, we have basically an array. So this is really a complicated little data structure here. Maybe closer to something that might do in reality when you start to break it down. All right, let's write the function. So we have the given information here, so we don't need to do that part, thankfully. So we're going to name the internal variable here meal, which will be of type string. Our return value will be meal object, right? That has all of these capabilities here. Let's get some curlies in there. And then we are just simply going to return meals and the current meal. All the syntax there, plural to singular and whatever. There's kind of a nomenclature for doing that. I don't want to do a sideline on that right now, but now we need to test. I have a couple here pre-created. I have lunch and breakfast. Right. Take a look at the difference in the output here. So lunch, well, that's not part of that structure, right? So lunch returns nil. Breakfast is part of the structure, and that returns an optional. And if you expand that, by the way, see if I can expand it. Doesn't want to let me, apparently. Well, you can see it down here. Okay, so it's down in the console, right? Now, if you're looking here and you're trying to figure out, this is a dictionary, right? And the key here is breakfast, and then the value is an object, right, that contains, that's complicated. Basically, it's a meal object that's based on this struct, where it has the property for food, which is an array of all the foods that you ate, and the calories total, right? And that's part of this struct, right? So the key is just the word breakfast, but the value is a struct, or really it's an object, right, with a complicated set of data. Right. And I like this example. I wish they had built it out more so you could maybe have dinner in there. But if you wanted, you could add dinner to it. You could even add a snack category, right? And then test it. All right. So let's move on here. It says iOS comes with a few different APIs for persistence or saving data. You'll learn more about this in another lesson. But for now, imagine an app. What an app experience would be like if every time you open the app, all your data was gone. Wouldn't it be frustrating? And very, very interestingly, and I'm just like a sideline, when I did the level 3 training, the data training, we broke the whole classroom into different teams. One team was tasked with the app that we were building to write the code to make the data persist. So you could run it, turn it off, come back to the simulator or your device, whatever, and then have the data come back, right? Because that we expect that from an app. That is a little bit more sophisticated. But let's move on here. Write a function that will check to see if your meal log, a dictionary like that in the previous exercise, is saved to the device. If it is, return the meal log. If it isn't, return an empty dictionary of type string any. And it says the code will return an optional string any. Okay. The code you should use in this exercise for retrieving something saved is user defaults.standard dictionary for key mail log. All right, so we're just going to copy that. If it returns nil, then no meal log has been saved. Call the function print its return value. All right. What I'm going to do here is I'm going to just drop this function in all at once in the interest of time efficiency. There it is. So we're calling it get saved log. The return value is an array of strings. Type any. We're going to do an if let here. So we're going to log it if it's possible for it. And we're looking for the key meal log. So if the meal log is there, then we'll pull it back. So we'll return the log if it exists. Otherwise, we're going to return, well, what's this? This is kind of a weird syntax. Well, this is the syntax for an empty dictionary, right? Because dictionaries have the colon in between the key and the value. So that's how you return an empty dictionary. We're going to need to call this. So I'm going to grab my print function here. Paste it in. Now we're going to get the saved log. And notice it is pulling back from the meal, right? All the information that's embedded into that struct, basically. Hopefully that worked for you.
Yep, worked for me.
Excellent. Working on it.
Yeah, working on it.
Yep,
Almost there.
I'll pause the video for a sec. All right, we're going to move on here. All right, so now we're going to talk about failable initializers. It says create a computer struct with two properties, RAM and year manufactured. I'm going to just start doing it right away. So struct computer with the capital C. Two variables, right? One is RAM. Call that an int, I guess. And the other one is another var for the year manufactured. You know what? It does say both have type in create a failable initializer that will only create an instance of computer if RAM is greater than 0. And if year manufactured is greater than 1970, but less than 2020. Right. And you could fudge that date. Makes you think that, oh, this book must have been written in 2020, right? So you could bump that up to 2024. Okay, here's kind of a computer trivia question here. Why 1970? Have you guys ever heard this one before?
Yeah, you taught this in the beginning of the web programming class.
I did.
You did, and I forgot it.
This is
I
really
should know it. I should know it too.
And it's not because we didn't have computers before that date. We did, right? But we didn't have the types of computers that we think of as being computers, right?
Mhm.
So really, you know, like the first nodes on the internet, you know, were created in 1969. And for the most part, most computer systems up until that time did not have a screen, did not have a keyboard, did not have a mouse. Try using that computer. That must have been a lot of fun. What was the input and the output? The input may have been punch cards or some other sort of maybe like a tape, you know, magnetic
Like the
tape,
IBM systems.
right? Well, precisely, right? And you know, strangely, a lot of those types of systems are still around running our banks and stuff. And the output was often either back to punch cards or out to paper, you know, and that's why we had those tractor feed, you know, paper things, whatever. But in 1969, in order to kind of like engineer the internet, they started building operating systems that were designed to network And then systems finally started getting screens, although primitive ones, and keyboards, so we could type in commands directly. And we were getting more of the type of setup that we had. And, you know, yeah, this is geeky computer history, but we just kind of think of that date as like there weren't really any, you know, like modern, you know, computers and operating systems prior to that point. So like every computer that you would buy going on into the future from there on in, if you didn't set the system clock, it would default to January 1st, 1970 is kind of like the ground zero date for, I don't know, the internet or computing era. You know, very, very silly, but that's how it operates, you know, so that I didn't make that choice, somebody else did. All right. All right, so if we're going to make a failable initializer, what we do is, and we learn how to do this, right? So we already learned how to do inits for structs, but notice the use of the question mark. So we're creating an optional initializer here. And we're gonna have RAM, which is an int. So we need that information. We also need year manufactured. I was hoping for some auto type here, but it's not kicking in. Thank you, Swift. Also type ins. Let's put in our curly brackets. And then we're going to say if RAM is greater than 0, and year manufactured is greater than 1970, which that's almost certain, right? And another thing, and the year manufactured is less than, and I'm going to put in 2024. That's the current year. Then we will self apply the RAM that's being fed into the thing that we're creating. Same thing with year manufactured. So we're taking the value sent in and applying it to the object we're creating, basically. Otherwise, if that if statement above is not true, we will just return nil, right? So once again, if we return nil, that's why we have the question mark. All right. So that's the lay of the land in terms of structure. We'll leave that on the screen. And now we're being asked to create two instances of computer question mark, notice as an optional, using the failable initializer. One instance should use values that will have a value within the optional. The other should result in nil. Use if-let syntax to unwrap each of the computer optionals, and then print the RAM year manufactured if the optional contains a value. All right, so this will take a few steps here to accomplish this. I'll code it down here. So the first thing is I'm going to do these one line at a time now, or at least one copy paste at a time. First one. So this is one that's going to fail. So the RAM is 0. That's a fail. The year in manufacture is 1960. That's also a fail, right? And then we'll create an if-let statement. So in other words, it doesn't create it unless we can create it. And if it does, it would output the RAM and the year manufactured. You see this results in nil. So what is being output? Nothing. I know you guys are anxiously or quickly typing the code here, but I'm going to move on with the example so we can finish up this playground. The next example is one that will succeed. So we have a RAM with apparently 16 gigs and it's manufactured in 2010. Let's make that a little bit more modern. Let's make it 2021. I think that's when my computer, well, not this one that I'm using, but my main PC was made in that year. This, of course, is a Mac. Okay. We'll use the same if-let code. We're just going to change the syntax on it so you could copy these few lines here. And I'm pulling them from the solution file. So this one will succeed, and because it does succeed, then we can extract the values. All right, and I'll just pause here for a second and let you guys catch. All right, let's move on to the last page. Hopefully you guys got that to work. All right, so on the last page of the playground now, and it says back to the fitness tracking app, and it says, have you ever accidentally tapped a button in an app? Right, it's pretty common, right? I do it all the time. I have like fat finger. I think I just have big fingers or something. You can decide that if a user accidentally taps a button to start a workout and then ends a workout within 10 seconds, you simply don't want to create a log of the workout. Otherwise, you'd have to go delete the workout from the log. Okay, so like in other words, we're setting a parameter. Right? It's kind of like if I'm recording a Zoom video and it's only 3 seconds long or something, you just get rid of it, that kind of thing. So create a workout struct that has properties, start time and end type double. Dates are difficult to work with, so you'll be using doubles to represent the number of seconds since midnight. So 28,800 would represent so many seconds, which is exactly 8 hours. So the start time is 8 a.m. Right? You guys got all that? Write a failable initializer that takes parameters for your start and end times and checks to see if there's fewer than 10 seconds apart. If they are, your initializers should fail. Otherwise, they should set the properties accordingly. So let's do this first part. And once again, I'm going to kind of speed the process by doing a little copy pasta, as my kids sometimes say. So I do a struct. We're going to set 2 doubles. We're going to do a failable initializer. And we're going to feed in start time, end time. Yes, I will paste. All right, and then I'm going to open, close curly brackets. I have an extra curly bracket here, or do I? No, I don't. It was just an accidental key press. Now inside here, I will set an if statement that if we can set it, and if I subtract the start time from the end time and it's less than 10, it's less than 10 seconds, we will return no. So that's kind of like the accidental, in the app. Otherwise, if they did intend to run it, right, then we will set the values inside the object we're creating. Right. Then we want to get to the point where kind of what we did in the previous example, we'll create one that will fail first and then one that will succeed second. Now, because we have a pattern for that, I'm not going to give you this code. What I'd like you guys to try, and I'll pause the recording for a second, is I'd like you guys to try doing it on your own. You can flip back a page and see what the syntax is, but I think you should get it maybe even without having to guess. And so try to create one that will fail and one that will succeed, and we'll see if you get it. So I'll give you like 2, 3, 4 minutes here. I think that might be enough. All right, let's go ahead and take a look at the solution here. So I'm going to first drop in the one that's going to fail. There's that one. Call it a fake workout. Notice start time and end time are less than 10 seconds apart. Right? And so the return value is nil. It's not going to go through. Now I'll put in one that's going to work. A little too far down. And so now these are more than 10 seconds apart, right? So now it will log it and it shows you the start and the end time because we're able to process it. Right, so that's the solution here, folks. I'll try to like tighten that up a little bit so we can fit it all on one screen. There we are. All right, I'm going to stop the video here. We've completed this playground. And when our next video comes out, I guess it'll be on to the next. But this one ends here.